Hackers just used an AI model to discover a zero-day vulnerability, write a working exploit, and plan a mass attack. This is the first time that's ever happened, and the only reason you're hearing about it is because Google caught them before they pulled the trigger. Google's threat intelligence group confirmed it on Sunday. The hackers weren't just probing for weaknesses, they were planning what Google internally calls a mass exploitation event. That's Intel speak for hitting thousands of targets at once with a single automated payload. Security researchers have warned about this for years. AI models that can find and exploit vulnerabilities without human guidance. It was always theoretical, conference talks and white papers, scary demos that worked in labs but never in the wild. Until last Sunday, when theory became a confirmed operation. Here's the attack chain. A threat actor pointed an AI model at a popular open-source web administration tool, the kind of thing sysadmins use to manage servers, DNS, databases. The AI scanned the codebase. It found a vulnerability that nobody knew existed. No CVE, no advisory, no patch. A true zero-day. Then it wrote working exploit code targeting that vulnerability. Then, and this is the part that changes everything, it planned how to deploy that exploit at scale across the internet. The specific vulnerability was a two-factor authentication bypass, not some obscure configuration edge case. A full authentication bypass on a tool that thousands of organizations use to manage their production servers. If the exploit had deployed, attackers would have walked straight past the login screen on every unpatched instance they could find. What makes this different from every AI hacking story you've heard before is the end-to-end part. Previous incidents involved AI helping with one step. Maybe it found a suspicious code pattern. Maybe it helped write a phishing email. This time, the AI handled the entire kill chain: discovery, weaponization, and deployment planning in a single pipeline. No human vulnerability researcher in the loop. Google said they assess with high confidence that the exploit was AI generated. In intelligence terminology, high confidence is the highest standard short of direct observation. It means multiple independent lines of evidence all point the same direction. They're as sure as you can be without literally watching the hacker's screen. The code patterns, the methodology, the speed of iteration, it all fingerprinted as machine generated. Google identified groups linked to China and North Korea as showing significant interest in using AI for vulnerability discovery. The specific actor behind this attack hasn't been publicly named, but the geography and operational patterns narrow the field considerably. These aren't random hackers in a basement. These are state-sponsored groups with budgets, objectives, and AI infrastructure that most private companies can't match. This is the arms race that cybersecurity researchers have been dreading. Nation-state hackers now have AI tools that can find 0 days faster than any human researcher on the planet. And the only viable counter is AI-powered defense, doing the exact same thing, but faster. The problem is that offense has a structural advantage. Attackers only need to find one bug. Defenders need to find all of them. In this case, Google won the race. Their proactive vulnerability scanning program, which also uses AI, independently found the same 0 day before the attackers could deploy their exploit. Google coordinated with the affected project to push a patch. Attack prevented. But here's the uncomfortable math. That's one win that we know about against an unknown number of attempts we'll never hear about. The ones that succeed don't get press releases. And here's the context that makes it worse. Anthropic's Mythos model, a frontier AI system built for advanced research, was separately benchmarked on exploit development. It chained multi-step exploits autonomously with an 83.1% success rate. That means a publicly documented AI model can already take a vulnerability description and turn it into a working attack more than 4 out of 5 times. The tools to do what those hackers did aren't some secret capability. They're getting better every quarter, and the benchmarks prove it. Mandiant's latest M-Trends report dropped another data point that should keep every CISO awake at night. 28.3% of all CVEs are now exploited within 24 hours of public disclosure. That number has been climbing every year. Now add AI to that equation.
An AI model doesn't need to read the advisory, understand the vulnerability class, and write exploit code sequentially. It does all of that in parallel. The exploitation window doesn't shrink from days to hours. It shrinks from hours to minutes. If AI can find and exploit 0 days before humans even publish security advisories, the entire model of responsible disclosure gets compressed to nothing. The gentleman's agreement, where researchers give vendors 90 days to patch, that assumed human speed attackers. Patch Tuesday, the scheduled maintenance window that enterprises have relied on for 2 decades, becomes a liability. Every day you wait is a day an AI model might have already found the same bug and written the exploit. Google hasn't disclosed which AI model the hackers used. used. And that ambiguity is itself a major part of the problem. It could be an open source model running locally with no guardrails. It could be a fine-tuned version of a commercial model with its safety filters stripped out. It could be a custom model trained from scratch on vulnerability databases and exploit code. Each scenario has completely different policy implications, and right now, we don't know which world we're in. Open source AI models are the wild card. They have no usage restrictions. Nobody's monitoring what you point them at. No API logs. No abuse detection. If a fine-tuned Llama variant or a Mistral derivative can find 0 days, you can download it, run it on a gaming laptop in a coffee shop, and nobody will ever know. The entire model of AI safety through API gatekeeping assumes that attackers are using your API. The sophisticated ones aren't. A skilled human vulnerability researcher might find one exploitable bug in a week of focused work. A really good one, maybe 2. An AI model can analyze thousands of codebases simultaneously, running 24/7, never getting tired, never losing context, and improving with every iteration. The economics of vulnerability discovery just fundamentally changed. Finding 0 days used to require rare expertise and significant time investment. Now it requires compute, and compute is cheap. Zoom out for a second. 2 weeks ago, researchers documented an AI agent autonomously writing a 17,000-line script to attack a water treatment facility's control systems. Last week, the Five Eyes Intelligence Alliance, that's the US, UK, Canada, Australia, and New Zealand, issued joint guidance specifically about rogue AI agents in critical infrastructure. Now, 5 days later, the first confirmed AI-generated 0-day exploit. The escalation isn't monthly anymore, it's weekly. Every major AI company has an acceptable use policy. Every single one says, do not use our model for hacking, exploiting vulnerabilities, or developing malware. And every single one of those policies is exactly as enforceable as the terms of service page that you scrolled past in half a second the last time you installed an app. The companies know this, the regulators know this, and the hackers definitely know this. The real question isn't whether AI can find 0 days. We now have confirmation that it can. The question is whether AI-powered defense can consistently find vulnerabilities faster than AI-powered offense can exploit them. Right now, Google says yes. Their AI found this one first. But Google also has more compute than most governments and one of the largest security research teams on Earth. Most organizations don't have that. Most organizations are running a 2-person security team and praying that their managed detection vendor catches what Google would catch. Practical takeaways. If you're running servers, patch everything today, not next maintenance window. If you're managing infrastructure, assume your current patch window needs to be cut in half at minimum. If you're running any web-based administration tool, audit your 2-factor authentication implementation right now, especially if it's the tool referenced in this report. Assume your internet-facing infrastructure is already being scanned by AI-powered tools, and segment your network so that when, not if, something gets through, the blast radius is contained. Step back and think about what we actually learned this week. This was the first confirmed AI-generated 0-day exploit. Google caught it because Google happened to be scanning the same software with their own AI at the same time. That's not a security strategy. That's a coincidence that happened to work out. The uncomfortable truth about successful cyber attacks is that the ones that work don't make the news. They don't get blog posts. They don't get confirmed by threat intelligence teams. They just quietly succeed. AI just crossed a line in cybersecurity. The first end-to-end AI-generated exploit was real. It targeted a critical authentication mechanism. It was designed for mass deployment. And the only reason it didn't work is that Google's own AI happened to find the same vulnerability first. We are now officially in the era of AI versus AI in cybersecurity. And the stakes are every server, every network, and every piece of critical infrastructure connected to the internet. If you want cybersecurity and AI stories that actually matter, covered every single day before the mainstream outlets get to them, subscribe and hit the bell. Drop a comment telling me whether you think AI defense can keep up with AI offense. I'll see you tomorrow.